get this idea of the behaviors of functions, right, in a graphic sense. And we know that functions can be increasing or decreasing. But when is that actually happening? What's actually going on there? The first thing I want to look at is visually. What's actually going on in this graph? And you can see that for increasing functions, when I read the graph from left to right, so I'm looking left to right, the function is going up, right? In a simple way, it's going up. And it doesn't matter where on the graph it is, but when I read it left to right, you can see that it's always going up in that direction, okay? And same for decreasing functions. If I read it from left to right, you can see now it's going down, okay? It doesn't matter where on the graph it is. If I read it from left to right, it's going down. That's what's happening in a visual sense. What's happening algebraically is that you can see as x increases, what happens to your y values? So as x goes towards the right, the larger positive values, your y is also increasing, right? Your y is getting bigger and bigger and bigger. And over here, your y starts off in the negative values, but as x increases, your y is slowly going towards 0 and is also increasing. So y also increases. And if we look at the algebraic definition of decreasing, this also holds, right? Because as x increases, the opposite is going to happen. As x increases, my y values are now decreasing, aren't they? My y values are decreasing. So there's an opposite or inverse relationship happening. So y decreases. Okay, so two definitions, visual and algebraic. But then they'll want us to apply that knowledge. And they'll ask us questions like this. So they're saying, find the domain on which y equals to x squared is increasing and decreasing. Okay, first things first, the domain. We know that that's a set of x values. So we're looking for the set of x values where this graph y equals to x squared, and that's just a normal parabola with a vertex at 0, 0. Okay. We want to work out when is it increasing, where is it decreasing. And again, we can actually do this pretty easily visually, right? We can see that from this point, it's going down. It's going down all the way up until this point here, 0, 0. Okay? And then likewise for increasing, after 0, it starts going up. Okay? So where is y equals to x squared increasing? Well, on this side of the graph here. So it's increasing this blue bit, where this blue bit is, and it's decreasing on this side of the graph. Now we're going to see this algebraically as well, right? As my x values get larger and larger and larger, my y values are also getting larger. And that's our algebraic definition there. And as my x values get larger and larger and larger this way, right, they're coming from the negative side and they're getting larger towards 0, okay, my y values are now decreasing, okay. So the set where it's increasing is x greater than 0, so that's the domain for A. And for B, it's decreasing when x is less than 0. If you're wondering why I haven't included the point 0 in my answer, that's related to something called calculus. And actually at this point here, 0, 0, your function is neither increasing or decreasing. But we'll have a look at that later.